I'd like to go over with you an additional technique for solving integration by parts that's really powerful, but in full disclosure is not something that I use regularly or in practice just because I sort of like the practice of doing it the so-called hard way. And this is the idea of the tabular method of integration by parts. So if I have to find something like x to the fifth sine of 2x dx, the problem with doing that is that that's going to require several iterations of integration by parts. It's going to require like 5 or 6 integration by parts to solve. And that can get really tedious really quickly. But there's a method, again, the tabular method, that allows you to set up and solve these in a very, very fast, very, very efficient way. So what you do is you pick u and dv, just like you would with normal integration by parts. But instead of setting up that whole integral with, uv minus v du, you construct a table, 2 columns. The first one is the u and the second one is the dv column. And you put your u here and your dv here. And what you do is, for each of these, as you go down, you are taking the derivative. Take the derivative of u all the way down. But for each of these, you don't take the derivative, you take the antiderivative. So you keep taking the antiderivative as you go up, or as you go down. So this one you take the derivative, on this one you take the antiderivative. And you keep repeating this process until you get a 0 here. So if you go all the way down and you get a 0, you know to stop. So this one you keep going until this stops. So the key to stopping is in this column. Then once you have stopped, so that gets us here. Gets us here. Then what we do is we take the rows and we go kind of catty cornering. The arrows aren't drawn super well, but you go one down, you go over and down, and you match up these terms. And we're going to multiply those terms together, but what we're going to do is alternate the signs. So in this particular case, this had a negative, but the sign is positive, so it stays. In this one, the sign was negative, but it has a negative, so it becomes a plus. There's a plus plus here, plus minus, minus plus, minus minus. So that actually should have been a positive there. My bad, which of course will lead to a positive here. My bad on that. So what we then do, once we have generated all of those terms, we just add them up. You just bring them all together into this. Now what I did is I grouped by that cosine of 2x and grouped by that sine of 2x, but you don't have to do that. And that generates this whole thing with a plus c on the end. So you just keep going really quickly, multiply some things up, tabulate it, right? That's the tabular integration. Tabulate the result, plug it in, and you get it. It's a very fast, very powerful thing, but again, I don't use it very often, so I can't speak to a lot. Now, I do know this much. I do know that if you end up here, like something like what you started with, like what we did where we had to add it back over, there is actually a way to do that. There's a way to figure that out. You draw a line like this way, and you do something with that. There's a way to do it. I apologize, I don't know what that is, but if you're more interested in tabular integration, there's a lot of really good resources that are out there to do it. It's just not something I've familiarized myself with, and I'm just throwing it in to give you an additional technique in your toolkit.